4-6 is the Hl Theorem. It's called the Hypotenuse Leg Theorem. We'll get to that in just a minute. With HL, okay, it looks like donkey, but remember we said donkey doesn't work, and this is why. These two pictures right here are why donkey does not work, because you have an angle that corresponds to an angle, you have a congruent side to a congruent corresponding side, and then you have another side congruent to its corresponding side. So this is ASS with ASS. Are those congruent triangles? No, this is the Hinge theorem, right? It hinged this way and it worked, hinged this way and worked, but you did not get the same triangles. So instead of saying ASS, there is a situation where it's going to look like ASS and it will work, but it's different. It has to be in a right triangle. Can you tell me the parts of a right triangle? What do we call these three sides in a right triangle? Two different names.
Right angle.
Anyone know what you call the side across from the right angle? The legs are the across from the right angle side. So these are both legs. Okay, the ones that form the right angle, those are legs. Anyone know the other one? Did I hear it?
Base.
Not base. Hypotenuse. This is called a hypotenuse. Okay, it's always across from the right angle. Always. It is always the longest side of your triangle. Okay, when it's a right triangle. Hypotenuse only shows up in a right triangle. Okay, so we're going to be talking about the hypotenuse leg theorem. You may call it HL every single time. Okay, now HL looks like you only need two things, a hypotenuse and a leg. It's not true. You need three things still. The first thing that you need is congruent hypotenuses. Okay, so we have to know that the longest side of a right triangle is congruent to the longest side of a right triangle to even be able to use HL. The second thing that you need is you need congruent corresponding legs. Okay, so one set of legs has to match up for you to be able to use HL. So there's your H and your L. But then the third thing that doesn't have a letter in this theorem is you need two right triangles. Okay, so in order to use the HL theorem, you have to prove all three of those parts. This is the part that often gets left off or done wrong. So I'll focus on that in a minute, but I just want you to understand where we're coming from. Let me tell you why HL works, because if you think about it, okay, HL is going to look something like this: a hypotenuse congruent to a hypotenuse, a right angle and a right angle, and a leg and a leg. Well, that to me looks like the donkey theorem, right? ASS with ASS. You just need to note that it's a right angle. Whenever it's a right angle, it's going to be HL if you have a hypotenuse and a leg with it. So if it looks like donkey, but you have a right angle and the hypotenuse is marked, it's going to be HL. Now here's the thing. You could do donkey, not donkey. You could do right triangles that look like this. What is that?
SAS.
That's SAS. So even if it's a right angle, you can still do SAS, okay? Or a right angle with ASA, you can still do that too. So just keep in mind, it has to be a hypotenuse and a leg for you to be able to do HL. Okay, let me show you why this one works and the other non-right triangles don't. If you think of this setup, if I were to extend this side so that this length is the same as that length, when I make that triangle, what's the measure of this angle? 90 degrees, because it's a straight angle, right? That we just put a 90-degree angle on one side. So in order to add up to 180, it has to be that this is a 90-degree angle also. Okay? Do you see anything else in those two triangles that's the same? Not the hypotenuse, the reflexive, right? The other leg is reflexive. So if you have two right triangles like this, SAS is actually what allows us to use HL. SAS proves by CP/CTC that HL will work. Okay, so that's only with right triangles because we can just extend that line. That's why it works. We're not going to dig into that any further. What I want to know is, are these two triangles congruent?
Yes.
Why?
Because the hypotenuse in one of the legs is congruent, and also they're both right.
So we know our hypotenuses are congruent. They're both 26, okay? We know our legs are congruent because they're both 24, and we know it's a right triangle because it has a right angle in it. So if you have that HL set up, those three things, you can say, are the triangles congruent? Yes, they are by HL. Okay. Yes, sir.
But if the right angle wasn't there, it would be yes.
If the right angle wasn't here at all, like if it just looked like this, so 26 and 26 with 24 and 24, if that's all you knew,
Oh, that would be not enough.
that would be not enough info. If they told you these angles are congruent, that would be SAS. If they told you these angles are congruent, but they didn't tell you it was a right angle, you can't use HL. You have to know it's a right triangle that you're working with. So this even would be not enough info because it's donkey and we can't use donkey. Okay? Okay. So here's what we're going to do. I have two proofs for you. Once we're done with those two proofs, you have the rest of the time to get started on the homework. Things to note when you're doing proofs. First of all, what do we always start with? The given. And what do you need to do with the given information? Mark it. Okay? Mark what you know. So if I know WJ is congruent to KZ, mark it. I also know WJ is perpendicular to KZ, so you can mark that with your right angles. I actually marked that one for you already. Mark what you know, okay? And call it given. So all of this information is going to go right there. Is there anything else you know in this picture? Yeah.
The middle line.
Can you name it? Yeah, Andrew.
Reflex line.
Reflexive.
That one.
What line? JZ. JZ is. Do you know that I get that every year? Like JZ never goes away. JZ is congruent to JZ because it's reflexive. Okay, so is that a hypotenuse or a leg that we just said?
Hypotenuse.
Hypotenuse. And mark it, right? That's the hypotenuse of my triangle. So right now, you have two congruent legs because that was given. You have congruent hypotenuses because we proved it with reflexive. You have to prove to me that you have two right triangles. And this is the part that gets done wrong most often. So far, all they've told us is that these lines are perpendicular. Okay, now when you see perpendicular in your given, chances are you are doing what? Definition of perpendicular. So what does it mean that those are perpendicular? What do we know because it says they're perpendicular?
Right angle.
They're right angles, right? So we have to say two things here. We have to say angle W and angle K are right angles. And that's because the definition of perpendicular, you may use the symbol every single time on that. I don't mind the symbol. So now we know they're right angles. We said we have to prove we have what? Two right triangles. Okay? So your next step is to say triangle JWZ and triangle ZKJ are right triangles. Okay, now here's my question. How do you know they're right triangles?
It says.
It doesn't say they're right triangles. I mean, we're proving they are.
I mean,
How do you know those two triangles are right triangles? What do they have in them?
right angle.
A right angle. What's the definition of a right triangle? A triangle that has a right angle, right? So your reason every single time, your reason for two triangles being right triangles is the definition of a right triangle, not a right angle. So many people tell me right angle right there. It's not the definition of a right angle. The definition of a right angle is that it's 90 degrees. The definition of a right triangle is that it has a right angle in it, okay? So I'm pleading with you. Memorize this step. It will always be the triangles are right triangles by the definition of a right triangle. We know it's a right triangle because we proved it has a right angle in it, okay? Questions on that? Okay, so now think of the three things. We have congruent hypotenuses, check. We have congruent legs, check. We proved we have two right triangles, check. What can we say? HL. We can say the triangles are congruent by HL. Questions on that? Okay, look at the next one. And I feel like I should have not put boxes there because I feel like this was throwing people off that I'm giving you the boxes. The boxes won't necessarily be there, okay? What is given to you is this. This is your given information. I should have just left the boxes out on both of those. What's your first step? Given. Okay, so all of that information goes here as the given. Mark what you know. So it says CD is congruent to EA. Okay, and then look at what they're saying and what they want you to prove. They want us to prove the triangles are congruent. In order to prove triangles congruent, you need three things. SSS, SAS, ASA, AAS, or HL, all five of them use three pieces, okay? So check what we have. Right now, we have two sides that are congruent. They also told us in the given this piece of information. AD is the perpendicular bisector of CE. What do you know because of that? What's congruent?
A, B, and BD.
Okay, not A, B, and BD. Look at what they said. AD is the perpendicular bisector of CE. So CE is what's getting bisected.
So AD is congruent to CB.
No.
CB, BE.
CB is congruent to BE. Okay, and this doesn't have to be your second step. It could be your fourth step if you want. Why do we know that? Definition of a bisector. Okay, and mark it. Now look at what else it says in that given. AD is not just the bisector, the perpendicular bisector. What does that tell us? Right angles. I heard someone whisper it. Was that you? Good job. So we're going to say right now, angle ABE and angle CBD are right angles. And what is the reason for that? How do we know they're right angles?
Definition of bisector.
Not definition of bisector, definition of, no. What did they give us in the given? Perpendicular, right? They told us they're perpendicular. That is the definition of perpendicular lines. Okay, so we know they're right angles, but what do we have to know to be able to prove by HL? They're right triangles. So we're going to say triangle CBD and triangle EBA are right triangles. And how do we know that? That is the definition of a right triangle, that it has right angles in it. Okay? Make sure that this is a triangle and not an angle. It's not the definition of a right angle, it's the definition of a right triangle. Then what? HL. The triangles are congruent. So look at what they asked you to prove. The triangles are congruent by HL. You have a hypotenuse with a hypotenuse. You have a leg with a leg. And you have right triangles. HL. Está bien? Oh, look at that. Impeccable timing. So good.